Okay, so we're actually going to look at this do now together because it sort of leads us into the lesson. It says given AB is congruent to CD. How would I mark that and what does that mean? Given segment AB is congruent to segment CD. How would I mark that and what does it mean? Sophia? Good. We put a tick mark for AB and we put a tick mark for CD. We put a slash and it represents that they're the same length. Then it says that AB is 8 units long. Well, if AB is 8 units long, what else can we conclude? That CD is 8 units long because they're congruent. Then it says that BC is 3 units long. Now, we want to find the length of A to C. Can someone tell me what are we adding together to find the total length of AC? AJ? Good. The length of AC is going to be 8 plus 3, which equals 11. Again, now we want to find the length of B to D. Can someone tell me what are we adding together to find the length of segment BD? You got it. So again, we're doing 8 plus 3, which is 11. How do these segments compare? How do AC and BD compare? They are, what's the word I'm looking for? Lexi? Congruent. All right, what do I want you to take out of this? We had 2 congruent segments. We had A, B, and C, D congruent. So we had 2 congruent segments. And then we added the same segment to both of them. So AB and CD were congruent. We added BC to AB and we added BC to CD. Did we not? Right? We had 8 and 8 congruent. We added 3 to 8. We added 3 to 8 on the other side. So if we have 2 congruent things and we add the same thing to both of them, won't the result still be congruent? That's going to be the addition property in proofs. There won't be any numbers. We're going to have maybe 2 things that are congruent and you add the same thing to both of them, the results will still be congruent. And guess what? That also works for subtraction. Oh, this is still addition. Okay, so here we're going to have angle EFJ, so this angle is congruent to angle HFG, this angle. Then we're being told that EFJ is 45 degrees, which means HFG is also 45 degrees. The last piece of given information that we're told is that angle HFJ in the middle here is 30 degrees. Now we want to find the measure of angle EFH, E to F to H, this angle right here. Can someone tell me what are we adding to find the measure of that angle? Michael? 45 degrees. You got it. It's going to be 45 degrees plus 30 degrees, which is going to give us 75 degrees. Then we're asked to find the measure of angle GFJ, G to F to J, right over here. Can someone tell me what are we adding together to find the measure of angle GFJ? Amanda? Again, 45 plus 30 degrees, which is 75. How do these angles compare? They are congruent. All right, what do I want you to take away from this? If we have 2 congruent angles and we add the same angle to both of them, the results will still be congruent. If we have 2 congruent angles and we add the same angle to both of them, the results will still be congruent. All right, if you remember the very first day of proofs, I told you all that every reason, when we write the 2-column proofs for the reason column, every reason will either be a definition a theorem, or a postulate. We've all known definitions before we even started this class. We talked about theorems, something that we can prove to be true, like all right angles are congruent or all straight angles are congruent. So we've spoke of theorems, and now today we're going to learn our first postulate. A postulate is something we know to be true. You can't prove it, but we know for a fact that it's true. So the first postulate we're going to learn is that any segment or angle is congruent to itself. Doesn't that make sense? That anything has to really be congruent to itself. So any segment or angle is congruent to itself. In proofs, we're going to call that the reflexive property. So in proofs, we're going to write reflexive. Anything is congruent to itself. Hey, we have 4 theorems that fall under the addition property, but you're really lucky. You do not need to memorize these 4 theorems. Anything that falls under addition in proofs, we are just going to write addition. So anything that falls under addition in proofs, we are just going to write addition. You do not need to memorize these 4 theorems that go along with addition. But we will read them. The first theorem: if segment is added to 2 congruent segments, the sums are congruent. That's like what we did in the do now. If we added the same thing to 2 congruent things, the sums are congruent. All right, same thing with angles. If an angle is added to 2 congruent angles, the sums are congruent. That's what we did in the do now. We added the same angle to 2 congruent angles, the sums were congruent. All right, something I didn't show you yet. If congruent segments are added to congruent segments, the sums are congruent. So an example of that theorem, the third theorem, is right below. Do you see how I've marked this? Based on my markings here, which segments are congruent? Based on my markings, which segments are congruent? Ethan? Excellent. So based on my markings, DE is congruent to BC. Again, based on our markings, what else is congruent? Jeff?
A, B, and EF.
You got it. A, B, and EF. So there's no lengths here, but let's just pretend. If AB was 8 units long, which other segment has to be 8? Because they're congruent? EF, right? If BC was 2 units long, which other segment has to be 2 units long? Because they're congruent? DE. What can we conclude about AC and DF? Wouldn't they both be 10, which would make them congruent? All right, so what do I want you to recognize here? Give you a second to catch up. So we had A, B, and EF congruent, so the segment on top is congruent to a part of the segment on the bottom. The other parts are also congruent. So I sometimes say it's sort of like adding tick marks. So from A to C, wouldn't it be 3 tick marks plus 2 tick marks for a total of 5 tick marks on top? And from D to F, wouldn't it be 2 tick marks plus 3 tick marks for a total of 5 tick marks on top? Right, so if the top tick marks match up with the bottom total tick marks, that's addition. Those total lengths will be congruent. So it's adding parts together, but their sums are congruent. You could do the same thing with angles. Do you see how this bottom angle has 2 loops through it and 2 loops through it, and the top angle has 1 loop and 1 loop? We can conclude that this whole angle is congruent to this whole angle. Because if you look, angle QPR is split into 1 loop plus 2 loops. 1 loop plus 2 loops, isn't that 3 loops altogether? If you go to the other angle, QRP, again, it's 1 loop plus 2 loops. 1 loop plus 2 loops, isn't that 3 loops altogether? So because the parts of the angles are congruent, the whole entire angles will also be congruent. That's also addition. So do you think AC is necessarily congruent to DF? Yes. Do you think angle QPR is necessarily congruent to angle QRP? Yes. So we spoke about addition, now we're going to talk about subtraction. I'm just going to show you. So here we have segment WY is congruent to segment XZ. Right, see how I marked it? How I marked this is really important. How I marked this is really important. Do you see an overlap from how I mark things, the congruent segment? So like the blue congruent with the orange congruent. Do you see an overlap in any part of that? Yeah, where do they overlap, the congruent parts? Good. Don't they overlap right here at XY? Because they overlap at XY, if I were to take XY away, so if I were to take WY and take XY from it, and I would take ZX and take XY from it, WX and YZ would end up being congruent. And let's see with numbers. Let's see what I'm talking about with numbers. So we were told that WY is 12 units long, and XY is 4 units long. So that means XZ is 12 because they're congruent. So how long is YZ? Someone tell me, how would I find the length of YZ? How would I find the length of YZ?
12 minus 4.
You got it. It would be 12 minus 4, which is 8. And then we have how long is WX? Well, again, we would do 12 minus 4, which is 8. So what happened? We took two congruent things, and didn't we subtract 4 from both of them? So we took two congruent segments and we subtracted the same segment away from both of them. The results will still be congruent. So two congruent segments and we subtract the same segment away from both of them, the result is congruent. So this is yes. We can do the same thing with angles. So look here. We have angle EFH. So this whole angle is congruent to angle GFJ, so it's congruent to this whole angle. Do you notice that the two congruent angles overlap at angle GFH? So the two congruent angles overlap at angle GFH. Again, if you have two congruent angles and you take the same angle away from both of them, the results will still be congruent. Let's see what we have. Angle EFH is 50 degrees, which means angle GFJ is also 50 degrees, so those are both 50. And angle GFH is 10 degrees. All right, what is the measure of angle EFG? What is the measure of angle EFG? 40. What did you do? Good. You did 50 minus 10 and got 40. What is the measure of angle HFJ? What's the measure of angle HFJ? You got it. You're going to do 50 minus 10, and it's going to be 40. Are they congruent? Yes. What do I need you to take away from here? If you have two congruent angles and you subtract the same angle from both of them, the results will still be congruent. All right. let's go through some given information and come up with conclusions. It's all about marking your diagram correctly. It's all about marking your diagram correctly. So here we have segment KO. Look how I mark this. Segment KO is congruent to segment KP. Look how I mark it. Segment NO is congruent to segment RP. We want to prove that what can we conclude? We want to know what we can conclude. I know there's no numbers here and there won't be any lengths in your proofs, but just to show you, to help you come to a conclusion. Let's say KO was 10 units long. If KO is 10 units long, which other segment has to be 10 units long? KP, perfect. All right, let's say NO is 3 units long. If NO is 3 units long, which other segment has to be 3 units long? Amanda? RP. Can anybody now make a conclusion? Ethan? You got it. Our conclusion would be that KN is congruent to KR. Somebody who's not Ethan, tell me, what do you think the reason for that would be, that KN is congruent to KR? What do you think our reason for that would be?
Just subtraction.
Subtraction, you got it. The reason would be subtraction. So if you have congruent segments and you take away congruent segments from that, the results are still congruent. We can do the same exact thing with angles. So let's look. Angle STE, so this big angle is congruent to angle WET, this big angle. And then let's keep going. We have angle STW, I'm going to call it angle 1 in here, is congruent to angle WES, I'll call it 2. And now we need a conclusion. I know there's no numbers, but let's give it numbers to make it easier for you to see. Let's say angle STE was 40 degrees. If angle STE is 40 degrees, WET is also 40 degrees. Let's keep going. Let's say that angle 1 is not 20. Let's say angle 1 is 30 degrees. Which means angle 2 would also be 30 degrees because they're congruent. Anybody think they could come up with any conclusion? Dimitri? You said WTE. Say it one more time. What's the other angle? WET. WET is the big angle. So you're right with WTE. Are you looking at this angle right here that I just called for? That would be angle SET. Excellent. So conclusion, angle 3 is congruent to angle 4. And your reason would be subtraction. You would do 40 minus 30. 40 minus 30 is 10. They'd both be 10. All right, generally when you're adding, let's just stay with whole numbers. Let's not bring integers into this. Generally when you're adding, do things get bigger or smaller when you're adding whole numbers, not integers. Generally when you're adding, do you get bigger or smaller?
Bigger.
Bigger. So we're going to use the addition property when what we're proving is bigger than what we were given. So use when proving that segments or angles are bigger than the given segments or angles. And generally speaking, and let's just stick with whole numbers, when we're subtracting, are things getting bigger or smaller? When we're subtracting, are things getting bigger or smaller? Don't they get smaller when we're subtracting? So use when proving that segments or angles are smaller than the given segments or angles. All right, you ready to see how this looks in proofs? Let's do this. All right, to save time, I am not writing out my given. On a test or quiz, you must write out your given. Now let's go ahead and mark up what we have. So here we have segment AB is congruent to segment FE. So I put 1/ on AB and I put 1/ on FE. Then it says that segment BC is congruent to segment ED. Should I put 1/ again? No, we've already used 1/. So what should I do now? 2 slashes. What is it that we want to prove? We want to prove that all of A to C is congruent to the whole segment F to D. Well, look what AC is made up of, 1/ and 2 slashes. Look what FD is made up of, 1/ plus 2 slashes. Well, 1/ plus 2 slashes is a total of 3 slashes. 1/ plus 2 slashes, isn't that also a total of 3 slashes? So AC is congruent to FD by what reason do you think? Addition, you got it. So we're going to say that AC is congruent to FD, and our reason is addition. All right, next one. Try not to go ahead of me because there's going to be something new that you haven't seen before that I need you to do. So here we have segment GJ is congruent to segment HK. I want you to mark it exactly as I'm marking it. Right, we want to prove, I'll highlight what we want to prove. We want to prove that segment GH is congruent to segment JK. Now, looking at the parts that are congruent, do they overlap, the parts that are congruent? Yeah, where do they overlap? Milo? HJ, you got it. They overlap right here. I'm going to put an X where they overlap. If I were to remove where they overlap, if I were to remove that segment where they overlap, which segments would be left? So if I were to remove HJ, that middle part, what segments would be left? Excellent, GH and JK. So what is going on here? If I take GJ and I remove HJ, and I take KH and I remove HJ, wouldn't I be left with GH and JK? So what am I doing? I'm taking away. What is that? That's addition or subtraction? Subtraction, we're taking away where they overlap. But because we're taking away the same segment from two different segments, there's an extra step in this proof. Anytime you have an overlap and you're either adding it or taking it away, you have to do this step. The step is saying, step number 2, you're going to say that that segment is congruent to itself. So you're going to say HJ is congruent to HJ. Your reason will be reflexive because any segment or angle is congruent to itself. And that's letting the reader know that we're using the segment twice. We're going to subtract it from the left side, and we're also going to take that same segment and subtract it from the right side. So it's sort of declaring that we're using this twice. And then once you declared that you're using it twice, then you could go on and say, okay, well, I'm going to subtract it. So GH is congruent to JK, and your reason is subtraction. All right, let's keep going. All right, let's look at angles. So given angle NOP, so this whole angle, congruent to angle NPO, this whole angle, then they're telling us angle ROP, so this angle down here, I'm going to call it angle 1, is congruent to angle RPO, which I'm going to call angle 2. I'll highlight what we want to prove. We want to prove angle well, I'll first write it in with a number. We want to prove angle NOR, which I'll call angle 3, congruent to angle NPR, which I'll call angle 4. All right, do we agree the big angle by O is congruent to the big angle by P? Yeah, big angle by O is congruent to the big angle by P that was given to us. And then angle 1 and angle 2 are also congruent. If I were to take away angle 1 and angle 2, wouldn't I be left with 3 and 4? Yeah, what is that since I want to take away from the congruent angles? Isn't that subtraction? Is there an overlap? Like here. Was like the same angle or segment used twice? In this one? Was there an overlap? There was no overlap. Since there was no overlap, do I use reflexive? No. Since there's no overlap, we do not use reflexive. So we just go straight into what we want to prove. Angle NOR is congruent to angle NPR. Subtraction. All right, so are you ready for something that's not so straightforward? Let's step it up a little bit. We have a lot of given here. I'm not writing it out, but I'm going to mark it up. Angle HEF, this whole big angle, I'm going to put a star, is a supplement to angle EHG, this whole angle. These are supplements. Then it says angle EHF, angle GFE, so I'll put a dot here, is a supplement to angle FGH. keep going. Then we have angle EHF. EHF. So that's, I'm going to call this angle 1 right here. Is congruent to angle FGE. FGE. So I'm going to call this angle 2 down here. And angle GHF, I'm going to call this angle 3, is congruent to angle HGE, which I'm going to call angle 4. Before I even look at what I want to prove, because isn't the whole point is go through your given, mark your given, and come to conclusions from the given? So looking at what we have, anybody come up with any conclusions up here with these big angles up here? Angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. Angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. That was given to us. Could anybody make a conclusion using that information if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4? Michael?
I can conclude that HEF is congruent to GFE because you add them together.
Say it one more time. HGF is congruent to?
I conclude that HEF is congruent to GFE because I can add.
So HEF right here, this angle and this one?
Yeah.
Okay, why?
Because if you add angle 1 and angle 3 together, it gives you. Probably I did that wrong.
You're right. Your thought process is good. We said the wrong angles though.
I conclude that EHG.
You got it.
Is congruent to HGF.
Excellent. So we're going to say that angle EHG, this whole angle, is congruent to angle FGH, that whole angle. All right, let's talk about why. So Michael saw that angle 1 and angle 2 were congruent and angle 3 and angle 4 are congruent. Well, if I add, let's say it was like 10 and 20. If angle 1 was 10 and angle 3 was 20, wouldn't that be 30 degrees up here on this big angle? Same thing over here. Since they're congruent, it'd be 10 and 20, which is a total of 30 degrees. Okay? Since the parts of the angles are congruent, the whole entire angles also have to be congruent. What is that, addition or subtraction? Addition, very good. So we're going to go ahead and write that. We're going to say angle EHG is congruent to angle FGH. That is addition. This helps us. Why does it help us? Well, let's look at what we want to prove first before I tell you how it helps us. We want to prove angle HEF. So we want to prove that this angle and this angle are congruent. Right now, this big angle E is a star and this big angle F is a dot. Can I say a star and a dot are congruent right now? No. Okay, but what do we know? We know that the big H and the big G are congruent, and we also know that the big E and the big H are supplements, and we know the big F and the big G are supplements. Didn't we learn a theorem that I made you memorize about congruent angles and their supplements? Does anybody remember that theorem? Omar? Good. Supplements of congruent angles are congruent. Aren't big H and big G congruent? And isn't big E and big F their supplements? So if two angles are congruent, their supplements are also congruent. So we could go ahead, prove what we want to prove. We are going to say angle HEF is congruent to angle GFE, and our reason is subs of congruent angles are congruent. All right, let's keep going. Let's do an algebra problem. So mark up our given information. Segment AD is congruent to segment EC. Then we have, look how I'm marking it, segment AE, which is 3x plus 20. And then also look how I'm marking it, segment CD is 10x minus 15. ED is 10. And we ultimately want to find the length of AD and EC. Oh, sorry, AD and AC. That later. Ethan? Oh, I wrote 10, sorry. ED is 8. Okay, so now let's look at this. We were only given, in the given information, that segment AD and segment EC were congruent. But we weren't told any expression representing AD or EC. We were told that AE and CE are congruent and CD are congruent. Can someone tell me, how do I know? This is fact. This is fact. Since AD and EC are congruent, I can conclude that AE and DC are also congruent. Can someone tell me, how do I know that? Based on the fact that AD and EC are congruent, I can conclude that AE is congruent to DC. Looking for a new hand. So I'm saying, how do I know? Since segment AD is congruent to segment EC, how do I know that I would be able to conclude that segment AE is congruent to segment DC? Looking at how things are marked. Ethan? You're on the right track. So the reflexive means we're using, because we have the overlap, so we'd have to use that DE twice. Good. What would we have to do with that DE? We have AD and EC congruent, but I need AE and DC congruent. So if we're subtracting, we're getting smaller. So I have small, so I have AD and EC congruent, but I need bigger. I need to say that AE and DC are congruent. So we're given smaller things are congruent, and we want to prove bigger things congruent. So it wouldn't be subtraction. What would it be? Addition. Look, let's say I said that AD was 2. Wouldn't EC also be 2? Which means AE is 10 and DC is 10. Isn't that addition? We do 2 plus 8, which is 10. All right, so that would 100% be addition. Why am I doing this? Because now I need you to realize that AE is congruent to DC. Therefore, we can say that 3x plus 20 is equal to 10x minus 15 to solve for x. So we'll get a 7x equals 35, so x is equal to 5. Now I'm going to plug in. AE is going to be 3 times 5 plus 20. So AE is going to be 15 plus 20, which is 35. Which means D to C is also 35. Now the first thing I'm asking you to find is AD. Does anybody know, AD is not 35. Does anybody know how I can find AD? AJ? Oh, you got this. So A to E is 35. How would I find just AD? You got it. It would be 35 minus 8. So we're going to get that AD is equal to 27 units long. So if AD is 27 units long, which other segment has to be 27 units long? Milo? EC. So then when they ask us to find AC, can someone tell me, in order to find AC, what would I be adding? What would I be adding to find AC? Christine?
35A and 35.
You said 35 and then I didn't hear the rest.
35A and 35.
Okay, but look what happens if you do 35, 8, and 35. This is 35 and this is 35. We're adding that 8 twice. Do you see what I'm saying? Because this is 35 and then from here to here is also 35. Do you want to try again? So we just want from A to C. 35 and 35.
Oh wait, 27, 8, and
27,
27.
8, and 27. You got it. 27, 8, and 27. Anybody add all that? Do we have an answer? 62, thanks. In the past, I've always put something similar to this on the test. All right, let's do another problem that's a little bit more involved. I don't know how much time I'll have, but let's see what we get through. So I'm going to independent number 6. So it says angle BAD, so this whole angle is congruent to angle FAD, this whole angle. Then, this is important, then it says that ray AD bisects angle CAE. You need to make a conclusion there. What is the conclusion if we are bisecting an angle? What is the conclusion if we are bisecting an angle? Demetri, no? Good, it makes two angles congruent. So what you do is you go to the middle part of the angle that's being bisected. Which point is the middle, C, A, or E? A, right? So you're going to go to point A. Inside that angle, do you see two angles inside by A? Should call it angle 1 and angle 2. Those two angles are going to be congruent. So my step number 2 is going to be angle 1 is congruent to angle 2, and the reason is def of bisect. All right, now let's look at what we want to prove. We want to prove that angle BAC, I'm going to call this angle 3, is congruent to angle FAE, which I'm going to call angle 4. So, I have this whole double loop congruent to this whole double loop congruent. By definition of bisector, we got angle 1 and angle 2 congruent. For what reason would I be able to say 3 and 4 are now congruent? Milo? Yep.
Subtraction.
You got it. Subtraction. So angle 3 is congruent to angle 4. That's what we wanted to prove, and our reason is subtraction. All right, we are done with this lesson, just so you know, because sometimes it takes me a while to put it up on Classroom. So if you have a study hall and you want to get your homework done, this is your homework. at the end, right here. I will put it on Classroom, but this is your homework. You must submit your homework onto Classroom. I need that documentation. So after you do your homework, you must upload it onto Classroom, attach it to the assignment. All right? All right, we're done.